Welcome to Day 8, the last day in Unit 7, Converting Parametric Equations. So what we want to do is take our two parametric equations and convert them into just one Cartesian rectangular equation. So what we need to do is eliminate the parameter, and the parameter is the variable t. So we're going to take our two equations. These are our two parametric equations. So what we're going to do is substitute one equation into the other equation to get just one equation with only the variables x's and y's. In other words, we're getting rid of the variable t. So not having two equations, just one equation with x's and y's, no t's. So what we need to do first is solve one equation for the letter t. So I could subtract 1, x minus 1 is a negative 2t, divide by negative 2. I have t equals x minus 1 over negative 2, or better yet, negative 1/2 x plus 1/2. Okay, so right now I have this equation. So every time I see the letter t, I can get rid of it and put in this stuff. So right here, I could take this y and say y equals 2 minus what I just got, negative 1/2 x plus 1/2. I can distribute a little bit this negative sign. Y equals 2 plus 1/2 x minus 1/2. And when I clean it all up, I get y equals 1/2 x. 2 minus 1/2 is 1.5, or 3 over 2. So what I've done is that I have eliminated the parameter of the letter t. It's gone. Now I should always make note what graph this is. This is a linear graph. It looks like a line. So that's what we're going to do today. Solve one equation for t, put it in the other one by substitution, and clean it up, simplify it, and see what we get. Solve for t. X minus 2 is equal to negative 3t. Divide by negative 3. I get t equals x minus 2 over negative 3, or better yet, negative 1/3 x plus 2/3. And I can put that in for this t right here. And I get y equals 5 plus, let's see, negative 1/3 x plus 2/3, or y is negative 1/3 x. 5 plus 2/3 is 5 2/3, or 17/3. And I'm pretty sure if I graph that, that is a line. Solve this for t. Add 3. X plus 3 is equal to 2t. Divide by 2. T equals x plus 3 over 2, or t equals 1/2 x plus 3 over 2. I could put that in for that t. I get y equals 9 minus 4, parentheses, 1/2 x plus 3 over 2. I could distribute a little bit. Y equals 9 minus 2x minus 6. And when I clean it all up, I get negative 2x plus 3. Again, I'm pretty sure that is a linear equation. I'm going to solve for this t by taking the square root of the whole thing. So I get t equals the square root of x. I can put it in here, and I get y is equal to the square root of x plus 1. And there's really nothing I could do to clean it up. And basically it is a square root type of graph, if you know what that looks like. I can get t by itself, so I better square everything. I get t equals x squared. I can put in for this t, and by doing that I get y equals parentheses x squared squared minus 3, or y equals x to the 4th minus 3. X to the 4th is called a quartic. It's still a U-shaped graph. I'm going to solve this for this t by square rooting it. T is equal to the square root of x, or t equals x to the 1/2. I have to put in for both these t's. So when I do all this, I get y equals x to the 1/2 cubed minus 5 x to the 1/2 plus 3. You can write it this way. Or, if you want to write it this way, to me they are the same function, same equation, doesn't really matter, and I don't even know what that graph looks like. I don't think there's a name for this graph. This last one, I want to solve for t. I have this t here. I'm going to double everything. So I get t equals 2x. I can put in for this t. Y equals 2 parentheses 2 x squared minus 3. Y equals 2 parentheses 4x squared minus 3. Y equals 8x squared minus 3. And that graph is a quadratic, or if you want to call it a parabola. They are all the same to me. And every single time we took our two equations, at one for x, one for y, we solve for t, we put in the other equation, and we were done with only one equation that had x's and y's, and that was it.